All right, Fetchers, what is up? It's time for you to get ready to take your first test in the virtual world in Math 100B, the Chapter 4 test. And so we're going to do a quick review. All right, so you've got a visual chart and the review in blue assigned. Those will be under your assignments. We're not going to write the assignments on the board. You can look that up in Canvas. You'll be good to go. But the first thing you need to do is make a visual chart. And I want to remind everybody that in sections 4.1 and 4.2, we talked about the laws of exponents. Okay? There were 5 of them. And we're going to have a little quiz here in just a minute that you can do with us to review those laws. There was the 0 and 1 rule. There was the product rule. There was the quotient rule. The negative exponent rule. And there was the power rule. And as typical with me, kind of writing sloppy when we do our review, is all this stuff you have in your notes. Okay, so those are the 5 laws of exponents. And we also talked about scientific notation. Okay, and then we got into polynomials. We have reviewed this pretty thoroughly. In section 4.3, we covered the basics of polynomials. In section 4.4, we covered how to add and subtract. 4.5 and 4.6 was all multiplication of polynomials. We just taught you today 4.8, which is division of polynomials. So what about 4.7? If you remember, 4.7 was more of all of this stuff, but the terms in the polynomial were bigger, right? They had more variables. But it was the same exact concepts that you learned in 4.3, 4.4, 4.5, 4.6, and 4.8. It is always up to you how to make your visual chart, okay? Whoops, that's one weird, awkward looking piece of paper. I can't even stand looking at that. I'm gonna have to do that one more time. We doing okay, cameraman?
Oh, we're good.
We're good? No technical difficulties? Okay, if you make your visual chart, I highly recommend that you have a big, huge box for the laws of exponents. And if you remember, we made a big chart. Did you guys make a chart too, Diamond Dave?
We did.
Absolutely, okay. And so we have the law, the hypothetical, the example, and then we have the myth buster, or proving why it works, okay? Taking the long way instead of the shortcut. And so I would have that big, huge chart with all 5 laws and the hypothetical, the law, okay, the hypothetical, the law, an example, and, you know, the proof or the myth buster that you do for all of those. And you'll have all the examples that you need there. That's what you need for your laws of exponents. And then would have a section about, did you want to say something? Yeah, we're going to do a section about scientific notation. Okay, scientific notation. So we're going to, I would go to the notes that we've provided you. I know in my class, I gave you some specific notes one day before we left on vacation. Keep calling it vacation, but I don't know what this is. Quarantine, before quarantine. And so, isolation, social distancing, whatever you're doing. I don't know how many of you are going to get married with that social distancing thing. So here's the deal. Dating life sucks. Okay. I don't have to social distance from my wife. I just want you to know, man. It's all good. Anyways, notes on scientific notation. We talked about what scientific notation is. We defined it, how to put a number into and out of scientific notation, how to multiply and divide with scientific notation. We're going to do some examples and talk to you about that in our review that we do here in a little bit. And you can add some of those examples inside of here. So the things for your notes and the examples. And then I go to your polys. And we had another big box about basics. If you remember, in section 4.3, we had A through I. Okay, and we defined a polynomial. We talked about how to evaluate a polynomial. We talked about coefficients of a polynomial, degrees of a polynomial, descending order, you know, all that kind of stuff, dot, dot, dot. I'm not going to review all those principles. You have notes on them. That should go in section 4.3. And if you wanted to put 4.3/4.7, because 4.7, like I said, it reviews all of this. Then I would have a little box. Just have a little tiny box, maybe about this big, for section 4.4. addition and subtraction. Yeah, you could go halfway here probably, it'd be fine. So you could have addition and subtraction of polys, okay, and we know that this is 1, distribute parentheses, and 2, combine like terms, and I would have a couple of examples. And then I actually would pop a section 4.8 up here, division of polys. And you may be like, why are you doing that? Because it's a smaller concept. And we just learned about this, any poly divided by a mono, any poly divided by a mono with the steps that we taught you. And then examples. And we gave you number 24 was our big example. I would put that in there. If you want to put 2 examples in there, I think that would be good. And then 4.5 and 4.6. And again, 4.4 is also 4.7, and 4.5 and 4.6 are also 4.7. This was multiplication of polys. And again, we had the 4 types. We had mono times mono, and a little bit about that. We had mono times any poly, and then we had the bi times the bi, and then we had the any poly, and you're going to see all of these on the test. They really emphasize multiplication of polynomials on the test. And so we taught you these, we gave you examples, you should make examples of all of those. I apologize to Diamond Dave's class. I'm kind of a chicken scratcher when it comes to reviewing what goes on the visual chart, because to be honest with you, you know what needs to go in here. So review that, make yourself a good visual chart, and we'll be right back. Yo, my brothers and sisters. Okay, so in preparation for your test, it's been a little while since we've done the laws of exponents. I think right now one of the best things you can do, it would be what we would do if we were live together in class, is I would give you these problems and say, go for it. Hopefully you have made your visual chart or you've worked on it somewhat. I recommend that you review the laws of exponents before you do this, the 5 laws that we talked about, and then try to do this. Definitely don't just watch me do these. Go ahead and pause your video now. Okay, so I've written all the answers in blue under each problem. This one is 2 to the 5th. This one's 1 over x to the 11th. This one is 1. This is p to the 13th. This one is 1 over x squared. This one is positive 2 to the 4th, x to the 16th, or if you multiply that out, 16x to the 16th. Either answer would be correct, okay? And then this one here is x to the 25th over y to the 15th, z to the 35th. Now we're going to spend the rest of the next probably 10 minutes in this lecture showing how to do these problems. So if you are like, hey, I got this, you know, then you don't need to listen to that part. But we are, after we go over this, we are going to review other things that are on the test. So go ahead and keep going, Diamond Dave. This right here, okay, this is the product rule, okay, and the product rule, okay, and Dave and I are we're gonna go back and forth on this a little bit. I'm gonna let him do a few, I'm gonna do a few, but the product rule says that things that have the same base, you can add their exponents. Now, one of the common errors that people make is they take 2 times 2 and they say that's 4, and they take the -7 and the 12, and I don't know what they do with it. Maybe they add it, -7 plus 12, and then they say that's 4 to the 5th. Okay, that is not the right answer. Okay, it's super common. When we have something like this, we're like, okay, we have x's, but when our base is a number, it's just so tempting for students. They want to multiply those 2 numbers. Please do not do that, okay? It's not true. Because this isn't 2, people. That's not 2. That's 1 over 2 to the 7th, which is like 1 over, you know, a few hundred something. I don't know. I don't even know, okay? And that's not 2. That's 2 to the 12th, which is 2 times 2 times 2. I mean, again, it's, you know, getting in the thousands range. Maybe, I don't know. I can't do it in my head. But the bottom line is that we can't multiply those 2's because it's not like I have 2 times 2. It's 2 to the -7th and 2 to the 12th. So we got to erase this. That's incorrect. Don't do that. What we have is we have a common base of 2, and we have a -7, and we get to add their exponents, which is so cool to take that shortcut, which in essence makes 2 to the 5th, which is our answer here. Okay? Say woo if you got that right. Woo! I hope you got it right. Okay, this is also the product rule. Okay, but it also incorporates the negative exponent rule with it as well. All right, so this ends up being x to the first plus negative 12, because you have the common base of x, which is then going to make x to the negative 11. But we learned that when we have a negative exponent, we have to put it in its opposite place in the fraction, and so this equals 1 over, this is up top, it's going to come down low, and the negative 11 becomes a positive 11, which gives us that answer there. Say woo if you got that right.
Woohoo! If you don't mind if I add something, one thing that I like to say, which I've seen helps my students out, is you've got your five different laws of exponents. Sometimes, like Brother Rich just showed us, multiple ones apply. I like to apply the ones that come earlier in the 5 and then do them later. So I could have tried to fix the negative exponent right away, but often I would find that students get more confused that way. If you start with the product rule or the quotient rule, or whichever one comes first, and then you do the other one, like negative exponent later, I found that it often cuts out on the confusion that students.
Let's show them what you mean, Diamond Dave. Show them if you had taken care of the negative exponent first. And I want to, while he's up there, I want to just make this one comment. I love what Brother Jameson is telling you, is that there's no order of operations to the laws of exponents. You can use them in whatever order you want, but he's saying that it can be more efficient to start with them in the order that you learn them in. They'll go a little quicker. Go ahead and show us if you had used the negative exponent first.
So if you had to use the negative exponent first, you're going to say, well, x to the negative 12th, I've got to get rid of that. That's going to become 1 over x to the positive 12th. But then I'm going to have to multiply it times this x. And then if I multiply it times this x, then I'm dealing with fractions, which we all, struggle with at some point in our lives. And so, except for maybe Brother Rich, I don't know if he ever struggled with fractions. But we take this and we say, okay, now we've got x times this, we've got to add them, and so, but we're adding on a fraction. And so it just ends up confusing a lot of people, but what we really do is we're saying, that it becomes, with it being of the bottom half, it does become 1 over x to the 11th. And that's kind of counterintuitive. But it does work the same way. It's the same kind of concept, but I find that it works better if you do the product rule first.
Yeah. Let me jump in here and show you guys one thing too, just so you get this. Again, I don't want to confuse anybody. I just appreciate what Dave is saying is that you could go this route. Let's say that you did this again. So that x is up top and so is the x to the negative 12. Well, that comes down to the bottom. Okay, and now we lose the negative, it becomes positive. So you have the x out here, but x times 1 would put that there. That's x to the 1. Now this becomes the quotient rule, which is x to the 1 minus 12, which then is x to the negative 11, which then you have to call that 1 over x to the 11th. You have to sequentially go through a lot more steps to get to 1 over x to the 11th versus just saying, hey, this is x to the 1, okay, plus negative 12, which is x to the negative 11th, and then you can say, hey, it's 1 over x to the 11th. That's awesome. Real fast, this is the last one I'm going to do for you guys for now, and then Brother Jameson's going to jump in. Anything to the 0 power, this is the 0 and 1 rule. If you remember, the 0 and 1 rule. Anything to the 0 power, okay, is 1. And this is ultimately, everything in the parentheses receives the power. So if you think about this, this becomes 3 to the 0, y to the 0. Well, anything to 0 is 1, so this is 1, and this is 1, so I have 1 times 1, and that's going to equal 1. Okay? All right, come on over here, Diamond Dave. Let's show them our stuff here with these. Okay? Go for it.
So, p to the 5th divided by p to the negative 8th. Here you have the quotient rule in taking effect. And again, there is a negative there. But I've found if you do them in order of product, quotient, then worry about the negative, you often simplify things. So if we take this, we're doing the quotient rule, so we're dividing exponents, we subtract them, so we say this is p to the 5th minus negative 8. Minus a negative becomes a positive, and so we say, well, this is p to the 13th. and I've gotten rid of the negative exponent rule. I didn't even need to apply it because I used the quotient one first. Okay, enough about that quotient. Let's take a look at this other quotient.
And Brother Jameson, on that, minus and negative, minus and minus makes plus. You end up with p to the 5 plus 8.
Yes.
Okay, and 5 plus 8 makes 13. Sweet.
So, here we've got x to the negative fifth divided by x to the negative third. Again, we've got the quotient rule, so we'll say, well, this is x to the negative 5 minus negative 3. Well, that's the same as saying x to the negative 5 plus 3. And so that is x to the negative second. Now, we can't have a negative exponent rule, or negative exponent. Applying that negative exponent rule, we now take this and we move it to the bottom of the fraction, put 1 on the top, and we have solved that quotient rule problem as well. Now let's take a look at this rule. This one applies the power rule. And we can't apply the power rule because it's a monomial in there.
I'm going to jump in, Brother Jameson. I'm going to have you do our last power rule one. I want to show you guys something. This one kind of can be a nasty problem sometimes for students. If you guys are cool, I'm going to erase a little bit of what you've done. So if you need to pause it, take a picture of the board or something on your phone to help you, whatever you want to do. I just want to give myself a little bit more space here to mess with this, okay? So on this one right here, the power rule says that everything in the parentheses receives the power, if you remember that, okay? So the last two we did were the quotient rule ones. This is your power rule. And again, everything that's on this quiz, it really is going to prepare you for the test. We are going through the types of problems that you will see on the exam. And so you have a problem like this. The big question here is, how did that negative become a positive? Okay, so we're going to talk about that here in just a second. So if everything in the parentheses receives the power, I have negative 2 to the 4th, because ultimately this is a 1, so it'd be like 1 times 4, and x to the 4 times 4, which would be negative 2 to the 4th, x to the 16th. Why is it then positive 2? Okay, remember, do these problems have equal signs? No, they don't. So are they solve or simplify? They are simplified problems. And our objective anytime we have to simplify a problem is to get it in its simplest form. I want to show you something interesting. Negative 2 to the first, that equals negative 2. Negative 2 to the second, that equals negative 2 times negative 2, which equals positive 4. Agreed? Okay? Negative 2 to the third equals negative 2 times negative 2 times negative 2. Well, a negative and a negative make a positive, but that answer is still going to equal a negative 8. See the pattern that starts to emerge here. Negative 2 to the 4th is going to be negative 2, negative 2, negative 2, negative 2, right? These two negatives make a positive. These two negatives make a positive, and so that makes positive 16. So you see, every time we have an odd exponent, okay, we have a negative final answer. Every time we have an even exponent, we have a positive final answer, okay? Just put a little mark there to detract from that. So in essence, if we were to multiply out, okay, if we were to multiply out this answer, because it's to the 4th, this would become positive, and so we get rid of the negative in the final answer, because if we were to multiply that negative 2 to the 4th completely out, all right, and we have to understand, we've talked about this in my class, it's really negative 2 to the 4th when you think about it. That entire negative is being raised to the 4th power because it's everything in this parentheses receives the power, including the negative. And that negative times a negative times a negative 4 times, negative 2 times negative 2 times negative 2 times negative 2. 2 times 2 is 4 times 2 is 8 times 2 is 16. All the negatives cancel out to make it positive. Now students ask often, which of these will be the correct answer on a test? I cannot answer that for you. Every test is different, and both of these are correct. And I know sometimes as students that frustrates the heck out of you, but if you can do it in your head, they usually multiply it out. Sometimes they'll leave it like this. And will they have both of these? We've talked about this many times. They will not have both, not on a multiple choice test, because it would be double jeopardy. They're both correct, so it'll just be one or the other, okay? Diamond Dave, why don't you come do this last power rule problem here? I'll erase this if you want to do this up here.
So, this last power rule problem, we have parenthesis x to the 5th over y to the 3rd, z to the 7th, parenthesis, all raised to the 5th. Everything in this monomial can receive the power through multiplication. So we say, well, we take x to the 5th times 5 divided by y to the 3rd times 5, z to the 7th times 5. X to the 5th times 5 is x to the 25th. Y to the 3rd times 5 is y to the 15th. And z to the 7th times 5 is z to the 35th.
Sweet, great job. Okay, that is our review of the laws of exponents. We're going to pause, and when you look up the videos, there will be a second video for the second half of the review for this test. Go ahead.